Can you imagine an event so unlikely that it's beyond human comprehension? Well, today I'm going to try to blow your mind with probability. First, let's warm up our brains and take a trip to Vegas. Now, have you seen this meme that claims that you are only 32 games away from Elon Musk's money if you have 100 bucks? Well, it's true. 32 doesn't sound like a big number. It must be possible. So let's do the math. In an American roulette game, which has 2 zeros, you have around a 47.3% chance of winning if you try to guess the color. Let's observe how this number starts to grow exponentially when attempting to win several times in a row. If you aim to win 5 times consecutively, turning your $100 into a nice $3,200, your chances are around 2.3%, approximately 1 in every 42 scenarios. It's starting to seem a bit unlikely and we're only 5 spins in. Well, what about 16 times in a row? This will turn your $100 into more than $6.5 million. But hold on, your chances drop to around 0.00064%, roughly 1 in every 156,000 scenarios, and we're only halfway there. Okay, straight to the point. If you aim to win 32 times in a row, you would transform your $100 into a staggering $430 billion. However, I'm afraid to tell you that your chances are approximately 1 in every 24 billion scenarios. It wouldn't be a smart plan to get rich. This equates to around 4.12 times 10 to the power of -9, or this number over here. Well, this is unlikely, but somehow definitely not impossible. I told you this was just the warm-up. Now, let's talk about something you might have already heard of: a deck of cards. In a standard deck, there are 52 different cards. What do you think the total number of combinations is? You guessed it, very big. But how big? Well, let's dive in. A deck of cards has 52 different cards, meaning that for the first card in our combination, there are 52 different possible cards. For each one of those 52 combinations, there are 51 different combinations, and so on. We can express this calculation with this symbol here. No, I'm not shouting the number at you. This is 52 factorial, which means multiplying 52 by all its consecutive descendant numbers. This gives us an astronomical amount of 8 times 10 to the power of 67 or 80,000 vigintillion possible combinations. Wow, this is big. But how big? According to the US Department of Energy's Jefferson Lab, there are close to 13.3 times 10 to the power of 49 atoms on Earth. This number is incredibly small in comparison to the 80,000 vigintillions. So yes, there are a lot of combinations, so many that if I were to choose my favorite grain of sand and you were to select a random one, the chances of you luckily choosing it and then winning the Powerball 3 times in a row would be higher than shuffling the same combination 2 times in a row. Actually, if we were to place 1 million machines on every planet in the universe, supposing there are 10 to the power of 30 planets, shuffling a deck of cards 1 billion times per second since the beginning of the universe, we would need around 185,000 times the age of the universe to find all possible combinations, assuming none of them repeat. Absolutely absurd. You can be sure that if you shuffle a deck of cards completely at random, the combination is unique. Now, let's consider the chances of shuffling every card on Earth and getting the exact same combination on every single one of those decks. You guessed it again, low. But how low? Okay, hear this. We can express the chances of flipping a coin 5 times in a row as 1 in every 32 events, a relatively small number. Similarly, we can represent the chances of winning roulette 32 times in a row as 1 in 24 billion scenarios. That's a little bigger, but still easy to write. We can even express the chances of hitting a specific pattern in a deck. It would look like this. That starts to get big, but it is still manageable to write. If we wanted to write the odds of shuffling every deck of cards without scientific notation, we would need around 600,000 packages of 500 sheets of paper just to write all the zeros. This is around 20 times the size of the Vatican. The approximate number, depending on the assumed number of decks, is hard to pin down, but it's roughly 1 in 1 times 10 to the power of 650 billion. Can you write it? This may be the most unlikely single event that is not theoretical and that humans could technically do and measure the results. How about attempting it next Christmas? Even if we were to analyze something slightly more unlikely, considering the magnitude of our universe, it is mathematically impossible for it to happen unless we have infinite time and resources. In that case, it could theoretically happen an infinite number of times. The number is so big that our minds can even completely comprehend its magnitude. Basically, it is astronomically more likely that you and your whole family win the lottery 10 times a second from the moment you were born until you die, without ever losing. Next time someone told you nothing is impossible, show them this video. Thanks for watching. If you enjoyed the video, please give us a like. And if you're interested in learning more about math, philosophy, history, logic, or whatever crosses my mind, be sure to follow the channel. I'll see you in the next video. Goodbye.